Hello, assalamu alaikum everyone. All right. Okay. So to be honest, I usually start the class on time, right? But unfortunately, we're like 10, 11 minutes late. And the reason is because so many things happened, right? The first thing was my light system, unfortunately, something went wrong. So this is all I can give you all today, right? I hope everything is clear. All good, right? The screen is clear, everything, the lighting is fine, right? Because unfortunately, my ring light stopped working. You can see, all good, right? Clear, no?
Yes,
Can you all give
yes.
me, okay. Right. So because of that, this is all I can do today. And then another thing, again, YouTube live streaming took some time and everything took some time. So let's not delay further. It's nice to have all of you here. So it's not like how you all are joining the session, right? It's you have to wait till the very end to get the benefit of this. And the reason I'm making this session free today is because most of you are struggling with this session. I mean, with this topic, right? So straight line, I mean, motions in the straight line lesson is quite easy because it's what? Grade 10, chapter 2, right? So y'all are supposed to be thorough with grade 10, right? But unfortunately for many of you, although y'all are in grade 11 now, some of y'all are in 2026 batch, right? That means y'all are going to do in December now. Although y'all are going to do in December, y'all are in grade 11, right? Y'all are still not thorough with grade 10 chapter 2, right? And that's not, I mean, I'm not saying it's a bad thing, right? It's okay because y'all are going to learn today, right? Whether y'all are in grade 10 or grade 11, y'all are still going to learn the lesson today. I'm going to go from the start, from the very basic, because this is a crash course. I can't sit and go through the textbook one by one example. I can't do that, right? I will be doing it in a summarized version, right? So let's keep the session interactive. You can answer to me through the chats to Eduate Academy, that this thing chat, right? So you can send your doubts, everything there. I'll be looking at it and then answering it, okay? Or you can also unmute and speak, right? But I prefer not unmuting because there are like 13 of you here, no? If you want, you can unmute because my students, they usually unmute and they're very energetic. So you can unmute also. But you can send in the chats, right? So it would take some, now that we started at 7:40, we might go until 9:40 or sometimes until 10 also. So try not to leave the meeting, okay? Try to get the maximum benefit of this, right? So I'll not talk too much. Let's jump into the lesson, okay? So we will first, I'll show you, right, how important this chapter is, right? Because for most of you are thinking that straight lines in the motion is a grade 10 lesson. It won't be of, of much use, all of that, right? So I'll show it to you how important this lesson is, right? So now as you can see on my screen, this is the past paper, right? Past papers that I've opened from 2016 to 2025, the past 10 years, right? So now in the 2025 paper, right, you haven't really got an MCQ. 2025, there is not an MCQ from this chapter, right? You have got, oh, it's an Azan. Okay, it's Azan. Once the Azan is over, please let me know. Okay, thank you, Ihsan. Yes, the azan is over, right? Okay, so what was I saying? So I was saying that in 2025, y'all were not given with a single MCQ. So there wasn't a single MCQ asked in 2025. So what does that mean in your year? If y'all are doing 2026, they might ask in MCQ, right? But MCQ is not the point. They have asked an essay instead, right? So there is no escape, right? Sometimes they can ask you in MCQ, sometimes in essay, or sometimes there are years where they have even asked in structured. I think it was 2021. Yeah, see? So they can ask in structure. There is no, you can't neglect a structure, no? That means you can't neglect this type of questions, right? This is compulsory. Essay means you can skip and go on, right? But I wouldn't recommend skipping this question because this is very easy. This lesson is one of the most easiest and my favorite lessons. So I'll make you all also love it by the end of today's session, inshallah, right? So yeah, try your best to stay attentive today, right? It might be hard with notifications, that this everything. So try to keep your full focus. Let's do this together, right? So like in the past few years, one thing I noticed was they have asked in essays only, mostly, right? In the back then, like before 2020, like 2000, if you take the past papers and see, like 2018, 17, and all of that, they have asked an MCQ. You will get like 1 or 2 MCQs. But that 1 or 2 MCQs is also a big deal, okay? You like 1 out of 40 is a big thing. I mean, getting 1 MCQ correct out of 40 is a good thing, right? If you can't get this 1 mark or these 2 marks, in vain, no, because it's such an easy chapter, right? So try to grab that 1 or 2 marks. So today we'll be doing the past 10 years of MCQs along with the theory, right? I can't really assure if we'll be doing essay and all of that. Essay, it will take some time. No, MCQ means pata we will do, right? So we will do the MCQs today, inshallah, right? So what I want to see is notice the pattern, right? It's important that you notice the pattern. The past, I think the past 5 years or so, they have asked essays. Before that, they have asked MCQs, right? So something might come for your paper. So please stay attentive. It's in your hands, right? So let's start today session, which is motions in a straight line, right? Okay, so I hope you have printed the tutes, right? If you don't have the tute, that's okay. I'll share it. Wait, where is my tute? Here. Okay, so this is the tute. Yeah. Okay, so this is the tute, right? I haven't included much because we'll be doing a lot of things, right? I will not be like sitting and will not be doing much with the tute. That's why it's such a short tute, today's one. The rest of it, these are some memes, okay? Don't study this. This is just for your, I don't know, to keep you all entertained and to keep you all happy. If not, you'll be depressed now with studying all of these lessons. So like, just for the fun of it, I included memes. So don't study that. So we'll just have to include a few things. The rest of it, you have to use full scaps, okay? Full scaps or book or whatever that you have, use it, right? So we will start with today's lesson, inshallah, right? Let's start. Okay, so motions in a straight line, right? So now, this is about it, right? So let's go step by step, right? So we have to learn a few definitions, right? So definitions in the sense, you have to know a few terms, common sense, okay? So when it comes to a few terms, you must know terms like distance, right? This is something from, I think, grade, I don't know when, you have been saying, let's go maybe from your house to the shop or somewhere to a certain distance you're going to travel in maths. So you have been learning, right? Let's say this is your house, okay? This is my house, Zainab. Okay. And this is Abida's house. By the way, Abida is my student and she's here, no? So yeah, this is Abida's house, right? So from my house to Abida's house, maybe it is, let's say, 160 meters. Okay. From my house to Abida's house is 160 meters. Okay. So that is a distance. Okay. And a distance has magnitude and does it have a direction? Does distance have a direction? Can you all tell me? Yes or no? Because I don't want to be talking alone. Do you all think distance have a direction? Because you all have studied this lesson, right? No, distance doesn't have a direction, right? So distance only has a magnitude. What do you mean by magnitude? It has a value, a number, right? It has a number or a value, right? That's what you mean by magnitude, because some of you all know something has a magnitude, something has a direction. You all know that perfectly, right? You all know that this has a magnitude, this has a direction. You all know that perfectly, but you all don't know what is magnitude, right? Magnitude means a value, a number, or something that you can properly define, right? So here this distance has a magnitude. It doesn't have a direction. You can say from maybe Dehiwala to Kolonnavar. It's, I think, I don't know, I'm just assuming, okay? It's, I think, 1,700 kilometers or something. Okay, something, I don't know. So I'm just saying, assuming, right? From the Hiwara to Kurun now, it's 1,700 kilometers. But can I say a particular direction? You have to go left, you have to go right, you have to go north, you have to go south. Not like that, no. You have to go through so many roads, right? There's not really a particular direction, no. So therefore, a distance, we call it as a scalar. Okay, what is a scalar? Scalar means something that only has a magnitude but no direction. It doesn't have a particular direction. It only has a magnitude, no direction. So one example is what? Distance. Sorry, yeah, direction. So one example is distance. Now scalar quantities. Scalar quantities means what? It has a magnitude, it has a value. Okay, but it doesn't have a particular direction. Like, you can't really say go to the left, go to the right, go to the north, go to the south. You can't say like that. There is only a value, like only a number to it. Another example is, if you can say, like another example, let me think of another example. Mass, your mass, right? Now let's say you are, I don't know, I think you are 40 kilo, I don't know, is that overweight? No, I don't know, right? Maybe you're 40 kilo, maybe you're 50 kilo or something, right? That is also a scalar. That's a scalar quantity. Okay, so the word scalar might sound like a big word. What is scalar? What is scalar really? Like, you might not know what I'm saying, right? Scalar simply means, in simpler terms, it means it has a magnitude. Okay, no direction. That's it. Just remember like that. Okay, scalar quantity simply means it has a magnitude, but it has no direction. What is magnitude? I told you. It means it has a number, it has a value, right? That's what magnitude means. Okay, just remember like that. So another example I said was mass. Your mass, your not your weight, your mass, right? Mass means 50 kilo. 50 kilo, or maybe, I don't know, 60 kilo. You don't say 60, I am 60 kilo to the south, or like 60 kilo downwards. You don't say like that, right? That's absurd. You can't say that, right? You just say scalar quantities that you all know. Anybody? Let's see if you all remember, if you all know, because this is more like a recap. Okay, you all can hear me, right? If I'm lagging, please let me know. Can you all mention more scalar quantities? Come on, what is this? Batman, my students also dead now. If this is dead, no more free sessions, okay? Very good. Suraya, speed, right? Speed can be another scalar quantity, right? Speed, time, yes, exactly, right? Energy, yes, Hasna, very good. Energy, right? So like that speed means now when you're running, when you're like running a marathon or a race or something, right? When you think about like when you say speed, okay, you don't really say the how, like you don't really say the direction. She's running in this speed to this direction. You don't say that. That's stupid, right? When it comes to your time also, you just say 6 o'clock, or like 6 seconds, 7 seconds. You don't really go and say 6 seconds to the north. That's I have never heard of it. If you have heard it, it's probably in another universe, because in our universe there's no such thing like that, right? And even when it comes to volume, right? Volume also, Abida has said, even volume is correct, right? Volume also, if you say 6 meter cube. So those are some scalar quantities, right? You don't really say that there is a direction. There is no direction. There is only a value. There is only a magnitude, right? So that is what you mean by scalar quantities, right? So what is the opposite of scalar? It is vector, right? So now scalar quantity is done. The opposite of scalar is called as vector, right? So scalar opposite, the vector. Okay. So scalar means, I told you what scalar is. Scalar means what? It has a magnitude. Okay, I just press mag. It doesn't have a direction. Then what is vector quantities? Vector quantities means what? It has a magnitude and it has a direction. Okay, so like the examples you all said for scalar quantities would be what? Mass, time, speed. I think Hasna said energy, and Abida said volume. So these are all scalar quantities, right? It doesn't really have a particular direction. It's just, you just say a number, that's it, right? Number with a unit, that's it, right? But when it comes to a vector, you say a direction also, right? Now here I say mass. No, mass means what? 50 kilo, 60 kilo, right? But when you go and when you like usually, how do you say, like when you go to an airport or something, you usually check the weight of the suitcase, right? You check the weight of a suitcase using a balance, a spring balance, right? That comes in newtons. So that is, that you check with the direction also. So that, so what I'm trying to say is, weight is a vector because we say that with a direction. Okay, although sometimes when we're finding, now when you go to the first lesson, although we don't really say 50 newtons downwards, 50 newtons upwards, we don't really say the direction. But when it comes to weight, we have to mention the direction. Okay, so that's why sometimes when you answer the questions, you have to say 50 newtons in arrow, at least downwards, or like 50 newton upwards. So this is very strict in A levels. Okay, in O levels, we don't see much because now only all are starting up, right? So for O levels, we don't consider the direction much. So maybe that's why sometimes you might wonder, how is weight a vector, right? But for A levels, they are very strict. Like when you're writing the equation also, like when you're writing the equations, you must write like this, like F equals ma. We have to write F upwards like that, right? So usually, not usually, weight or force or whatever, that comes as a what? A vector. Because why? We have to show the direction, and there is a definite direction, right? Weight, it usually acts downwards. Why? Because gravity is down. So because of that reason, weight usually acts downwards, right? So some others we can say. Now from mass, I said weight. Why? Because mass and weight, they're connected, right? You know that, right? Mass 50 kilo means, what is your weight? 500 newtons, right? Because 50 times 10 is 500 newtons, right? That's like a bit of common sense, but it's okay if you don't know, okay? You don't mind me saying common sense often. If you don't know, please learn it now, right? So like, although we have this thing where when people ask you, what is your weight, man? And then you say, you don't say 500 newtons, no, we say 50 kilo. But that's actually wrong, okay? But I'm not saying now, from now on, to start asking people, what is your mass? If you ask that, they might think you're a bit crazy, but no, but actually, right, we ask people like, what is your weight? You don't ask, what is your mass? So, but weight, usually you have to say it in newtons, right? So if your weight, if your mass is 50 kilo, your weight is what? 500 newtons. What is the other 10 from? Can you all tell me? So 50 kilo times 10, what is the other 10? Can you all tell me? Does anybody know? 50 kilo times 10, 10 something is 500 newtons. No, so I'm saying that 50 kilo is the mass, right? 500 newtons is the weight. Then what is this 10? How did this 10 really get multiplied? Absolutely correct, Abida, right? It's the gravity, right? The gravitational acceleration, right? Even Hasna has told that, gravitational acceleration. So that, what is gravitational acceleration, will not be done today. It will be done in the next class, inshallah, right? So the 10 is actually the gravitational acceleration. So you multiply that by 10 and then you get 500 newtons, 10 meters per square second, right? I will not write the unit in all of that. It's an acceleration value for the gravity, right? So therefore you get the weight. Okay, so that is that. Okay. And then for time, if I can't really relate time to another vector, there is not really something like that. But when it comes to speed, when I'm relating speed to another vector, like a similar thing, I'm trying to like relate, like mass and weight, they have a relation, right? Same like that, speed and velocity, there is a relationship. So you might not sometimes find these terms familiar. If you're like just now starting grade 10, you probably wouldn't know what is velocity, right? And I don't expect you to know. I will teach it to you step by step, right? And another thing is distance. right? The vector is, can somebody tell me what's the vector? Somebody, anybody? If you want, you can unmute, okay? Because I feel like suddenly my class is quiet, because usually it's like everybody talks, everybody responds, right? Yes. Very good, Abida. Very good, Suraya. Suraya, right? Yes. So, it's the displacement. Okay. So these things, now displacement also, there is actually, I know you all can't see after place, there is ment, okay? I know you all can't see, but that's all my camera can afford to capture. So like displacement has a direction, okay? Distance doesn't have a direction. For displacement, of course, you have to say, right? 10 meters to the left of your house, 5 meters to the left. Now, next I'm going to teach you what distance displacement is, so don't worry. So I'm just trying to make you understand what is scalar, what is vector, right? So these are some examples of vectors, right? Some others you can say acceleration, right? Magnetic field. So these are some other vectors, right? And of course, force, right? Now, when it comes to weight, it's also a type of force, okay? Weight is a type of force. Tension is another type of force. Not the tension you get after exams, but like the tension when you're trying to, you know, find the tension of a thing, right? I'll tell you all about that, all of what all of that is when that other lesson comes, work, energy, power. So there only we talk about tension and all of that. The other thing is, oh, magnetic field, right? Even magnetic field, we have to mention the direction, whether it's inside the page or outside the page, all of that, right? And when it comes to scalar quantities, some others are density. Density, you don't really say no density of whatever is not, you don't really say the direction, right? You just say the magnitude, density of something, right? And pressure. So these are all that I can think of. If you all have other stuff that I haven't included here, please do let me know. So I want you all to first, we'll go to the tute and include this and come back, okay? Where is the tute? And if I'm fast, okay, if I'm talking too fast, because my students are used to me talking too fast and talking too much. So if you all are not familiar with me talking too much, you can stop me and ask me to repeat, okay? I will not scold you. Yeah, so this is the one. Quantities, right? So I did not start with distance displacement yet. I just took that as an example for scalar and vector. So you don't have to write anything here. If you all don't have the two, don't worry. Just take a full step and just draw this, right? Quantity is divided into two, vector quantities and scalar quantities, right? So under vector quantities, what are you going to write? You're going to write this. You're going to say, no, I have already written on the board. No, I have written a different way. But what you can do is just write, there is a magnitude. Put tick, magnitude. Where is my, this thing? Yeah. You can say have a magnitude, or just put a tick and say magnitude. Have magnitude. Don't copy, okay? Just think from your head and write. Okay, if not, there's no point, no. Because by the end of today's session, you should be able to understand this, not just listen and wait. You should be able to do something, right? Have a magnitude, have a direction. That's only vector quantities. What is scalar quantities? Have a magnitude, no direction. Okay. Sometimes, okay, this one you study actually in A levels only in detail. So when you go to, I don't want you to go to A levels and think, oh my God, I was taught lies. So I'm going to tell you, usually when it comes to scalar quantities, sometimes it's not that it doesn't have a direction. It has a direction, but there is no definite direction. You get me? Sometimes, a certain thing. Now, if you talk about pressure or something, okay, like if you take pressure, right, of a substance, right? Let me draw and show you. I don't know if YouTube people will be able to see. Okay, well, I'll just stop sharing with you. Okay, so I can erase it also. Okay, so now when it comes to a thing, like we'll talk about a ball or something, right? We are putting it in a, I don't know, in a beaker of water, right? So this, okay, it's filled. We'll say it's filled with water, will you? It's like a beaker filled with water, okay? And there is a ball immersed in it. So the pressure is usually, we say, it's acting. Now the pressure is acting everywhere. No, we know this. No, in the pressure lesson, hydrostatic pressure lesson, you usually learn it, right? That the pressure of something acts all directions, whatever in water, in liquid or whatever, you know that the pressure is acting in all directions, right? So can you see that the pressure does have direction? No, it's acting in all direction. So it can't be a scalar, no. Then you might ask me, right? You might be like, Miss, you said there is magnitude, there is no direction, and pressure is an example. No, right? I'm saying it doesn't have a definite direction. There's no one direction. No, it's acting in all the direction, you know? So that's what I actually mean. So I don't want you to get the wrong idea. So I'm giving you the right idea. So according to your understanding, just saying that there is no direction is enough, right? But I don't want you to go to A levels and think, oh my God, I was taught lies, right? So that's why I'm saying pressure, it has a direction towards all the sides, right? So because of that, you can't really say it has a definite direction. So that's why it's a scalar. Similarly, even others, sometimes it can be the same thing, right? They might have so many directions or they might not have a proper direction, right? So that's what we mean by scalar. Did you all understand? Any questions? Any questions? Any questions related to the lesson? Because someone is asking if I'm from Ilma International School. Yeah, I'm from Ilma. Okay, Abida understood. Others understood, right? All good though? Okay. So if you have any questions, please do send in the chats or stop me and ask, okay? Right. So yeah, let's go back to the tute. This is supposed to be a crash course, okay? But unfortunately, we're going a bit slow because I don't want to go rush like a crash course. It's fine though, right? Yeah, so back to the tute. Please include all the examples. Don't look at the board and copy, okay? Because that's not the point of this session today, right? What you're going to do is you're going to maybe first, if you're not thorough, if you don't really know the examples, at least look once at the board, okay? And try to remember it, okay? Because today it's not just going to be a session, another session where like joining and listening to a bayan or something, and then just trying to, I don't know, just trying to get the information by osmosis or something. That's not what you're going to do today. You're going to sit there, you're going to study with me today, right? So that you don't have to again open the book and study this part of the lesson, right? Although this might seem like a very easy part of the lesson, this question usually comes, right? So look to the examples, try to remember 1, 2, 3, 4, 5, 6, 7, 8. There are 8 scalar and 1, 2, 3, 4, 5, 5 vectors, right? So try to memorize it now and try to write it in your on your own and check if you have written the correct things and let me know. Once you are done, please raise your hands, okay? So what I'm saying is write the examples by memory, not by looking at the board. So write the vector quantities, write the scalar quantities. And if you have any questions in the meantime, please ask, okay? I mean, questions related to the lesson. Okay, and yeah. So once you are done, please raise the hands. That way I know you all are done. Okay, soon do it. Okay, we can't waste time with all of this. There's so much for us to do. 10 years worth of MCQs have to cover. Okay, Suraya done. Somebody else also done. Who's somebody else? Asma done. Also, my students here, don't be shy to ask questions. Okay, Zuha done, Riha done. Because usually they stop me and ask questions. And usually the class is very, I don't know, we talk a lot, right? I mean, I talk a lot, but they talk a bit more. So y'all can unmute also, okay? Okay, I will not wait till everybody's done, okay? I will just give like another 1 more minute. Soon do, okay? Can't be wasting time over these small things, no. I'll just give 1 more minute and then we will jump to the next part. Also, 2026 batch, you all only have 4 months more, right? So I'm hoping that you all are preparing and you all are not busy with FIFA and everything. So try to put your focus lock in now, okay? Okay, so almost everybody is done. Okay, a few more seconds left. Okay, right. So yeah, let's go to the next part. So that's about scalars and vectors really, okay? Nothing big. From that, we can actually do an MCQ. So shall we do MCQs and come back? Let's go for 2000. Wait, let me check. Listen, okay, now from this small part that we studied, they can actually give you the first MCQ of your paper. So imagine what a nice moment it would be for you. Let's go and try an MCQ and come back. 2016, they have asked an MCQ. Let me see. 2016. I think the first one, right? See, which of the following? Isn't it so babyish? Like you can just get 1 mark. Okay, 1 mark is a huge deal. Okay, so which of the following is a vector quantity? Can you all send it to me personally soon? Which of the following is a vector quantity? Vector quantity means what? And everything. Soon send it to me personally, right? Don't send it to everyone. Then others, they will also look and they will send no. Send it to me personally. Hasna, very good. Who else? Riha, very good. Rukaiya, very good. Suraya, very good. Abida, very good. Asma, very good. Okay, my mouth is hurting now. Okay, Hafsa, Mariam, very good. Okay, right. Ah, no, Mariam, check your answer again. Okay. Okay. So which of the following is a vector quantity? So what is vector? Vector means there is what? Both a magnitude as well as a direction, right? So we already learned that. So speed, I told you it doesn't have a direction. No, like you don't say I'm going in this speed in this direction. No, that's wrong, right? There is no direction for speed. For distance also, there is no direction. You don't have a particular direction. No, sometimes you would say, I'm going from the river to Colonnavi. You have to go left, right. You will say like so many directions. You can't really say one particular direction. No. So distance can't be a vector. That is wrong. I mean, you can't really say that, right? Where is my, give me a minute. I can't find my, found it. Okay. So distance, no, you can't say that. Speed, you can't say that. Time. Time, you don't say direction, right? You don't say 5 seconds to the left. 5 seconds, wait, give me 5 seconds to the left, okay? You can't say that, no, it's, I don't know, you don't really say a direction for time, no? So it's funny to me. So no, time you can't say. So weight is the answer, right? I told you, no, mass, it is, you can say 50 kilo. But weight, you have to say 500 newtons, maybe to the south, maybe to the north, right? So vector quantity, the answer is answer number 1. Most of you got it correct, right? So 2016 done. 2019 is the next one. 2019 the third one. Let me see. Okay. You know why I include past papers and not the model papers? Because you all will have the past papers, okay? It will be there on your table, but you don't need to open it. So that's why I do past papers than sitting and doing model papers with you, all right? So which of the following is a vector? So can you all answer this? Send it to me in the chat soon. Can't be taking a long time. Oops, yeah. It's easy, man. It's very easy. Very good, Riha. Very good, Hafsa. Sometimes I may not say your names, okay? Because there's too many of you sending it. Very good, Abida. Very good, Hasna. Very good, Asma. Asma, check your answer. Very good, Rukai. Wait. I'm getting. Rukai, check your answer. I think y'all are a bit tension, no? So like, be calm, okay? Because these kind of questions, you don't go wrong because you don't know it. You go wrong because of carelessness. Surya also correct. Okay, Asma correct now, right? Okay. So now here say, okay, which of the following quantity is a vector? Okay. So clearly, vector means again what? There is a particular direction and a magnitude, right? So like I said, now the list I gave is more than enough, to be honest. They will not ask more than that, right? When it comes to energy, work, it goes hand in hand, okay? Work and energy, it goes as, it's the same thing, right? So therefore, work is a what? It's a scalar, right? Energy, work, whatever, that is a scalar, right? Pressure, like I said, it has directions to I mean, it doesn't have one particular direction. It has so many directions. Like you can say a pressure of a thing, okay? The directions will act in so many different ways. So you can't really say one particular direction, no. So that is also a scalar. Now the problem is distance or displacement. Now, like I said, I have been saying this a million times. I don't know why most of you said 2, right? Distance is a scalar. There is no direction, right? I'll draw it and show it to you next how it works, right? And when it comes to displacement, it happens in one direction, right? So therefore, the vector is what? Displacement, right? So answer is answer number 1. Many of you got it correct. Only some said distance, right? So that's why I had to correct you all, right? And one last question, 2024. So see, okay, they have at last given this in 2024. So what if by your luck they give this for your paper, right? Say Amin. Because they can, they might. And if they do, you're the lucky batch. Where is that? Is it the first one? I think it's the second one. Yeah. Of the following pairs, the pair of vector quantities is. So what's the pair? Now this time they're not asking. It's like in a game you have beginners level, intermediate level, suddenly advanced. So this is like the advanced version. So you have to make sure that both answers are correct. So can you all send me? Okay, you all have sent it so quickly. Maybe you all have done this paper before, no? Okay, Hafsa, correct. Suraya, correct. Asma, check your answer. Abida, correct. Rukeya, correct. Riha, correct. Mariam, why not pressure? Okay, so Mariam, pressure, like I said, there is no one particular direction, right? So when it comes to a substance, when we talk about a ball or something, okay, pressure is a scalar, no? It's a scalar. Why? There is only a magnitude, right? You just say it as 100 pascals. You don't say 100 pascals towards the downwards or upwards, right? Because pressure doesn't have one definite direction. It has to have like a one particular direction. You have to be able to say like 100 pascals downwards or so on, right? But pressure you should acts in all directions. You study that under hydrostatic pressure. If you haven't, don't worry, you will study it. Pressure acts in all direction. It doesn't act in one direction. So therefore, pressure is a scalar, not a vector. Right. Zuha, correct. Okay. So now here this answer, this question, right? Vector quantities, right? So force is what? Force is a, wait, let me see. Yeah, force is a vector. Why? Because I said now if you take the chart and see, you can see, right? Force is a vector. It has a magnitude and a direction, right? I know I'm using this color. Right. Okay. Force is a vector. Mass is a what? It is a scalar. It only has what? A magnitude, no direction, right? Pressure is a scalar. Like I mentioned now, it has so many directions, not one particular direction. It has so many directions. Acceleration, maybe you have studied, you may have not studied. It is a vector, right? I will explain what that is. You will learn. This entire lesson is about what? Displacement, velocity, acceleration. So by the end of today's lesson, not today's lesson, by the end of this lesson, you will learn this very thoroughly, right? Speed is a scalar. Work is a scalar. First, you write this, okay? You don't be like a pandit and be like, I can figure it out at once. If I see the answer, I will know. Don't be like that. Take your pencil or pen or whatever on the paper. Also, you write it, right? And then velocity is a vector. Displacement is a vector. So by this, if you read the question after that, the pair of vector quantities, oh my God, okay, the pair of vector quantities would be the fourth one. Both are vectors. This is scalar vector, scalar, vector scalar. So therefore answer is answer number 4. Okay, yeah, so that's it about those. So now see, okay, the past 10 years you have done those questions. You're all good to go, right? That's it. I think before 2016 there were a few, but I'm focusing on the past 10 years, right? Okay, so now let's go into distance and displacement. Okay, my lighting looks very aesthetic, no? Like the yellow soft lighting, because usually it's very bright. I don't know, the light isn't working. So I hope this is fine. Okay, right. So now let's talk about let's go back to my house and now this time let's take somebody else's house, okay? We talk about my house and let's go with Suraya's house, right? Uh, okay. So now I actually took my nephew's car, okay? I brought his car also just to show you all, okay? He was crying. Okay, so now I can either go to from my house to Suraya's house like this, right? I brought his car, okay? So I can go like this, at once. Okay, I can go like that. Or I can go like this, maybe like that, and then come to Surya's house. I can even go like this and then somehow end up in Surya's house. I can do that in two ways. I can go to Surya's house either how? From my house to Surya's house like this, or I can go from my house to Surya's house how? Like, I don't know, like in different ways. Like, what is that? Parangia Kotagia Vage. So if you know that history saying, like this, right? So we can go in two different directions. So if I draw the pathway, it's either going to be one shot like this, or it will be like this, like this, like this, like how they took that who Portuguese, right? I can't remember history, but how they took the Portuguese to this thing, I don't know, to the what? To the king's house, right? So that way, right? So what I'm trying to say here is, right? Either way, we are going to Surya's house. From my house to Surya's house, we are going. Only thing is, how I'm going is different, right? From my house to Surya's house is just one line I can go, but instead sometimes I might take the longer route, right? So this one shot pathway, right? How, like me just going from here to here in the shortest possible distance is what you call as the displacement. What is a displacement? It's just a fancy term to say the shortest route, shortest way of going from my house to Surya's house. But let's say I take the longer route. I go like this from my house to, I don't know, I go from the hills and I don't know, from all these bins and all the Wangu and everything. And then I come to Surya's house. That is called as the distance. And now you should be able to understand the difference of a scale and a vector quantity now. So distance, there is no particular direction. You can't say direction. No, I mean, here you can just say north and then you have to say west, I don't know, sorry, east, and then something, and then you have to say so many directions. You can't really say one particular direction, right? So therefore, distance is a what? It's a scalar quantity, no? While displacement, one direction, which is not the band, okay, one direction means the one direction, right? So to the east or something, therefore it's a displacement, it's a vector, right? So this is the difference between a displacement distance and the vector and the scalar, right? If I show it to you in a proper way, right? So what is a displacement? It is the shortest distance between 2 points. Okay, what is the distance then? The total path that is traveled, the total route that we are going, the total path, right? That is what you mean by a distance. Either way, both of them have the same units. So you don't have to get confused. What is a unit? That means you say 100 kilometers, 100 meters, whatever. The unit is this, okay? So units are going to be the same. Kilometer, meter, I don't know, whatever the meter, megameter, all of the meters. So the units are same. The only thing is what? One has direction, one has no direction, right? So maybe if you say north, 100 kilometer to the north, then this way you can say, this is a displacement. If it doesn't have a direction, I haven't said north, south or whatever, then that is a distance, right? So you can, we can go to the tute now and write that there. Where is the tute? Again, if you all don't have the tute, please take a full step or something and write it, okay? And after the class, you can print it. Yeah. Here. Where is that? Here. Okay, so distance, what I'm expecting here is just write the definition, right? What is displacement in your own words? Like you can try to figure out, right? What is displacement? Let's go with displacement, will you? Displacement is the shortest distance, basically. Distance, same thing, okay? But it's the shortest possible pathway. Shortest distance is what you call as displacement. Shortest distance between 2 points is what you call as displacement. What is distance then? The total distance traveled. I mean, total path travel. So I'm asking what is distance, and I'm saying total distance travel. Total path. Okay. Whatever path it is. If you go, I don't know, if you want to go to Jaffna or something, you go through, I don't know, Kurunagala somewhere, and then you go and land there. It doesn't matter how you go, as long as you go. That's what it matters. Right? So that's what you mean by distance. But displacement means you just say, I go north. Right? So that's what you mean by displacement with a definite direction. Right? And you can just say, you can put a curly bracket maybe and say the unit You can put a curly bracket and maybe say the unit is meters. Okay, unit, write unit. Okay, I can't write using my, okay, not bad again. Okay, unit, and then say meters. Okay, unit, meter. Yeah. So that's about that. If you want, you can also draw what I have drawn. You don't have to draw Surya's house and my house. Maybe you can draw your house and your friend's house or something. Maybe somewhere here or like somewhere, I don't know, somewhere if you want to draw, just so you can understand, you can draw it. Okay. Yeah. So far, if you have understood, can you raise the hands? If you have understood, raise your hand so that I know you all are there. Okay, Abida understood. Others understood, right? Okay. Right. Okay. So yeah, I'll stop screen sharing. Okay, so from that, we can't really do a question. I was wondering if we can do a question. I don't think we can. So let me go to the next part, right? So now I'm going to introduce you. Now, I'm not going the order of your textbook where they first talk about distance, then talk about displacement, then talk about velocity, or that. I'm just going to go in the order that I like, right? In the way that you all can understand, right? So distance, displacement, we have spoken about, right? And then I'm going to talk about speed, right? So because we were initially speaking about speed, I'm going to jump to speed, right? So we said we have spoken about speed, right? In our day-to-day life, we say, right, this bugger was going in a high speed, and although we say, we talk in our colloquial terms, we say that, right? Speed we talk about generally in our day-to-day life, right? What exactly is speed? How do you actually calculate speed from distance, right? So this is something that you all might know, you all might not know, right? This is something that is very simple, to be honest, right? Speed is equals to distance over time. What is it equal to? Distance over time. That is what you mean by speed, right? Basically, a certain distance. Now, like I was talking initially, from my house to, again, Surya's house. Okay, suddenly our houses became a circle. Okay, don't mind that. Okay, so like we say the speed that I'm traveling. Okay, let's say from my house to Surya's house, let's say it's 150 meters. Okay, and maybe the time it took was 5 seconds. I don't think that's possible, but okay, let's just take 5 seconds, right? So how can I find the speed? Speed is simply, you just put it to that equation, right? Don't think too much. How is it distance over speed and all of that? You don't have to really care, right? Just go and put it to that equation, right? 150 meters over 5 seconds. And then after it's maths, right? Cut it. Then you get 30 meters per second. This is the speed, right? I know you all can't see after that, no? I'll just write it this side, will you? 30 meters per second. This is the speed. This is how fast you're going, right? How do you find the speed or how fast that is going? By dividing that distance with time, right? The distance of the time, you have to just bring this equation out, and then you find the speed. That's what the meme was about. Okay, on the tute, if you can see the meme, okay, let me show the meme. Where is the meme? Yeah, teachers act like this is how the world will be, right? Finding the speed, you have to solve and find it. Now, right now, when I'm just showing that I'm a teacher and I'm showing you that this is how you find the speed. But in real life, we don't really calculate the speed, no. It's just there, right? But somehow we have to study it, right? There, whether you like it or not, right? So basically, this is how you find the speed, right? 150 meters divided by 5 seconds, and then you get this. This is the speed, right? So we will do questions about this, okay? So what I'm trying to say is, in this lesson, it's mostly about equations, right? Sometimes you might feel like, what is this? So many equations, I can't remember all of that. That's how it is, right? It's not so many equations. I will tell you all the equations that we need, right? What you can do from your end is, if you feel like this equations are what's confusing for you, take a piece of paper, okay, and write all the equations down. If you all had joined this year's January Elevate webinar series, I did physics. So there, in my tute itself, all the equations were there, not just from this lesson, from all the lessons, right? So, but what you can do is, since if this lesson is difficult, take the a paper, foolscap or A4 sheet or whatever, write all the equations. Okay, speed equals distance over time, acceleration equals velocity over time. All the equations, you write it, and you just don't keep it like that. You paste it on your wall, in your study space or anywhere, paste it somewhere that you can see and revise it, right? Always every day look at it, right? That way you won't forget it. Because when it comes to questions, it's not that the question is difficult. You can't remember the equations. Or sometimes this is a maths problem. That's it. It's nothing else, right? These questions, it's not because you're weak or it's because you're stupid. It's because you don't know the equations from the basics, right? You just don't know the equation. That's the reason. Or maybe it could be your maths. You're weak in maths. It's not nice. It has nothing to do with physics, right? So this is the equation for what? Speed, right? Distance over time, right? What is the unit? Meters per second. How do you find the unit? What is the distance unit? Meter, right? M. M is meter, right? Divided by second. Okay. So therefore, you can write it like this. In short, you can just put I don't know, you can put like this and write it instead of writing the division like this, because this is very, you don't write it like this in science. So you can write it like this if that is easy for you. Or you can bring the what seconds up. When you bring the second up, you know what happens? If you know mathematics, indices, if you bring the second up, it becomes ms minus 1. Because this 1, when you take it up, it becomes a minus 1. I'm teaching maths to you, right? Or if you feel like that is so complicated for me, I might forget the minus, you can just go with this and write. No problem, right? So these are the units of what? Speed, right? So yeah, can you include this in the tute, please? Let's go to the tute and include it there. Where is the tute? Oh. Speed. Okay, let's just write it here. Okay, let's just write the unit, the what equation and the unit. Okay, so you don't have to. There's in the book, I think they have given the definition for that as well, right? If you want the definition, you can write it. But never mind, you can just write this. It's basically, you can say distance traveled per unit time. From the equation itself, you can tell the what definition. It's that simple. Okay, what is speed? Distance per unit time. Per is, because there's a division, we say per unit time, right? So you can just write the equation and maybe you can write the unit there, right? Okay. So I'll just familiarize you all with the units and then we will go with the questions and then let's go with the graphs, okay? Right. So I think that was enough time. Soon, right? Okay, I can't go slowly, so let's go fast. The other one is this, right? So now, just like speed, okay, there's something called as mean speed or average speed. Okay, just press AVG, it's average, write it fully, okay, average speed. So, what exactly mean speed or average speed is? It's like we talk about the total distance over total time. So right now, it doesn't make sense, obviously, right? Just because I say, no, you might not see a difference. What do you mean by speed? What do you mean by mean speed? You might not see a difference. But when we do questions, you will figure out the difference. For now, you just know it this way, right? Total distance traveled over total time taken. Okay, you can write this also there, right? For now, you just know it like this. You might get the difference when we are doing the questions, right? Okay. So, the other thing is, right, about velocity. Now, similar to distance, or distance is the scalar quantity. Distance over time, speed equals distance over time. Speed is the scalar quantity. What did I say was the vector quantity? It was velocity, right? Velocity was the vector one. It's like couples, This is the couple of the what? Scalar. This is the couple of the vector, right? Because this one doesn't have a direction, but the velocity has a direction, right? Has a definite direction. When you're saying a velocity, when you're saying like 10 meters per second, right? You have to say, if you just say 10 meters per second, it's a speed. If you say 10 meters per second to the north, it's a velocity, right? So therefore, when you talk about a velocity's definition or the equation, you don't say distance over time. The top person has to be a vector too, right? It's going to be displacement, not a distance. Okay, because why? Velocity, I told you, it has direction, right? So therefore, the displacement only has to be there. It can't be a distance. If it is distance over time, it is going to be something that doesn't have what? A direction. Distance also no direction, time also no direction. That means speed also no direction. You get me? Velocity, it has direction, right? Displacement also has to have direction. Time, it doesn't have direction. That's okay, right? We don't have another person, another substitute for time. No, time is time. We don't have a couple for time. Okay, that's why initially also I did not put an arrow and right next to time the vector, right? So velocity is equal to displacement over time, right? Again, right now, you can't just say displacement over time, you have to say change in displacement. Okay, my bad. Change in displacement. So again, by these equations, you're not going to understand anything, right? I'm just saying the equations I'm going so that I can teach you the next part about the graphs and the main part of the lesson, right? So if you feel like I don't understand these equations, don't worry. You're on the correct I don't know in the correct path, right? So right now, just write these equations on the tute. It'll make sense to you later, right? So when it comes to displacement over time, again, it's the this thing is the same thing, right? The unit is the same, meters per second or like this, ms minus 1, right? Both are meters per second only. So please go and write this on the tute. Okay, so here it is change in displacement. There it is just distance. Okay, that's the difference. Okay, why is it change in displacement? It will make sense to you when I teach you the next part, right? So for now, write this down on the tute, right? So once you are done, please raise your hands because I don't want to go rushing. I don't know how to share the tute. No, should I share? There's nothing to share. No, just write it here. So the definition for velocity is actually change in displacement per unit time. So the same equation, you just put a per and write it. That's the equation for velocity, right? You don't have to panic when they ask what is velocity in the essay or something. Don't panic. Write the equation. From the equation, try to get the definition. What is the equation? Change in displacement over time. Then what is the definition? Change in displacement per unit time. When you say per unit, it usually means the division part. You know, if you see definitions, you will understand it. Per unit the this part, this one. Per unit time. Okay. Right. Yeah. So maybe I'll tell, should I tell the other part? No, no need. Right. Now let's go into the graphs, right? So now I'm going to go into the graphs and teach you step by step about the graphs, right? Okay. So now for an instant, right? So let me just go into this thing. So we'll say a person. Okay, let me take someone's name from here. Zuha, right? Now let's say Zuha is going from on a straight road. Let's talk about a road like this, right? Zuha is walking to a salon, right, to have a haircut, right? From maybe to a point from A to B. Okay, now this is the type of questions that you get. Now I just went through the equations and now I'm going to now it's like this, okay? It may feel like I first taught you plain rice and now I'm doing biryani, okay? Because honestly, this is how you get in the exam, okay? So basically what happens is even in your school, what they might do in maths, when you're studying maths also, in school they might teach you like plain rice, but but when it comes to the term exams, it's like biryani because you don't know, like everything is connected. Sometimes they wouldn't have taught you, right? So that's what I'm going to do now, where I'm going to go a deep jump, right? If you have done these questions, it's Baba. But for people who are studying for the first time, it might feel a bit advanced, right? So pay attention and keep all distractions aside, right? So let's say a person is traveling from A to B on like a, not person, whom they say Zuha, right? Zuha is going from A to B, right? Zuha is walking from A to B on a straight road for what? To have a haircut, right? But give me a moment, give me a second. Okay, right. So I was talking about Zuha, right? Going to have a haircut, right? Oh my God, Zuha doesn't even have hair. Okay. Okay, so Zuha is going to have a haircut. Okay. So she's going from A to B, and then what she did was, okay, now she went to the salon. Now this is the salon, right? She's going to the salon and she's staying there for how many seconds? Let's say, okay, she's staying there for uh, I will not take minutes, okay? I know it's not possible. You know, in real life, you can't stay in a salon for 10 seconds and come back. You would barely have your hair cut, right? They would take like hours and hours, no, not hours, like minutes, no. So, but I will take it as seconds, okay? So don't mind the logic of this scene, but then just think about it, right? 10 seconds, she's going to stay in the salon, right? And then she's going to come back home. Now, this is her home, Zuha's home, right? Zuha's home, okay? And then she's going to go to the salon 10 seconds there, have a haircut. In 10 seconds, I don't know what they can do, but just imagine you can, you know, there is like a robot or something, and they're cutting the hair and they're sending her back home, right? So this is the kind of questions they can give you, right? And for these kind of questions, always draw a diagram. Not just the way I do it. They might just give it to you in words. You know, sometimes they might confuse you a lot. Always draw a diagram in a way you can understand. It doesn't have to be fancy. It doesn't have to be colorful. You don't have to sit in the exam and draw like nice diagrams. No, just roughly draw a sketch. Okay, so that you can understand what is really going on. So now this is a diagram that I drew based on a scenario, right? And then they have given you a displacement time graph like this. Like this, okay? A displacement time graph. So this is the part. When you see graphs, you all get scared and you all feel like running away. But graphs are the easiest part of this lesson. Okay, it's not like the maths graph. No, I'm not saying maths graph is hard. I love maths, but I'm just saying this is very easy, right? So bear with me. So it's a displacement time graph that they're giving. Okay, time is in seconds. Okay, so now they're asking what is her distance? Now we'll say this is 5 seconds. Wait, she went and then she stayed for 10 seconds and then she came 15 seconds. Okay. So this is what happened. Okay. So you must be able to read the graph. Sometimes you all might find it difficult to read the graph now. So what is happening here is, right, when it comes to a displacement time graph, first she is going. Now Zuha is going, okay, for 5 seconds. Now this is the going. Now she's walking and going, right? And in constant velocity, she's going. And then she's staying in one place, stationary. She's staying in one place. Now, this line means she's staying in one place. And then she's coming back. That's what this means. This slope means, right? So, this means Zuha is going, and then she's staying in one place. Stationary means one place, okay? Not the stationaries that you use. At rest. That's what stationary means, right? And she's coming back. Okay. So, this is what it means, the graph. Reading the graph can be difficult. Okay, sometimes when you study velocity time graph, acceleration time graph, the problem with you is you sometimes get confused. And how you can avoid the confusion is by doing a lot of questions, right? Because this lesson is not about theory, it's about doing questions, right? Okay, so now to go, she's taking how long? 5 seconds. Okay, and then staying there 10 seconds, and then coming back another 5 seconds. Let's say 20. Yeah, 5 seconds, right? Okay. So now the first question I would ask is, can y'all right, okay. Can y'all tell me her distance in can you tell me her distance in 15 seconds? Can you tell me? I'll just give you all to answer. What is her distance in 15 seconds? Can somebody tell me? Unmute and tell her anything. What is the distance in 15 seconds? From the graph you can tell, because here I did not say any distance to. From the graph, read and tell me. What is her distance in 15 seconds? Distance or displacement? Distance in 15 seconds. Somebody. Very good, Hasna. I don't know if others have sent. I didn't see. Okay. It is 40 meters. How do you see that? Okay, I'll tell you how you'll see that, right? So the problem is this, no, you can't read the graph no properly, so I will tell you, right? So first you draw a dotted line. If that is confusing for you, draw a dotted line to connect the graph, right? And then you try to understand, okay, so now they have only given the time and they have given this thing, right? So the scenario is here. Now forget the scenario, forget this incident. Now you know what happens. No, that's it. Now you try to relate this graph to the scenario and all good, right? So in 15 seconds, I asked you what is the distance, right? So go to 15 and go up like this, right? Maybe take a pencil and draw it. And then see there's a dot here now. And then try to come to the y-axis. Now from the x-axis 15, you go like that, take a pencil and then you come here. What is the value? 40 meters. If they ask you the distance in 5 seconds, then how do you find the distance in 5 seconds? Take your maybe another color. There is another color. If they ask you the distance in 5 seconds, again go like that. Stop where it stops in the trapezium, in this whatever the but the going back, coming, whatever this thing happens. So stop there. Always stop with the trapezium and then see where it goes in the y-axis. That is exactly where, how much distance she has traveled. Whatever the graph, okay? This is not just about the displacement time graph. Even with velocity time graph, if they ask you, maybe we'll say here is the velocity, okay? This applies to all, okay? Velocity, acceleration, whatever. So if they ask what is the velocity, don't get scared, right? Okay, somebody is asking me, what about 20 seconds? Let's see, right? If they ask about velocity, right? Same thing. Okay, if they have only given, if they have given you the values and they're asking you what is the velocity in maybe 10 seconds, right? If they ask you the velocity in 10 seconds, how do you try? They haven't even labeled 10 seconds, man. So you will have to find out where 10 is. 10 is in the middle, no? And then you go dot, 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 dot. Wherever there is the trapezium is there, you stop there and then jump. Go to the y-axis and see where is it. 40 meters per second then, right? So always go to the to whatever they have drawn there and then skip to the y-axis, right? So somebody asked me how, now if it is 20 seconds, then what is the what displacement, right? We'll see. Somebody asked what is the displacement in 20 seconds. So in 20 seconds, do I have to go up? Do I really have to go up? No, right? Because can you see the trapezium is itself, it's a part of the trapezium, right? Trapezium is there, right? You get me? Like you have to go to the trapezium basically. That's our goal, okay? Just imagine the goal is to go to the trapezium. Now, in this scenario, it's trapezium. Sometimes it could be a triangle. Sometimes it could be a square. Sometimes it could be, I don't know what. It could be different shapes, right? So in this scenario, this is the trapezium is our goal point, right? So this is the one, right? You don't have to go up. Trapezium is already here. So directly from the trapezium, you go to the y-axis. Then what is the displacement? 0. This starting point of the graph is always 0, right? You know that no in maths. So 0 what? Meters. You got it? Understood? Any questions? I don't know if you have studied this before, but this is how you find out the displacement or the distance, right? And then maybe we have to, now let's say they are asking the distance from her house to the salon. Okay. Now if they're asking the distance, okay, from her house to the salon, what exactly is the distance? We should actually now, displacement means you just have to talk about her going and coming. That's it. Distance is what? Short route, no. Displacement, my bad, okay. Displacement means Zuha's house to the salon, that direction. That's it, that distance. What is distance to go and to come back? Okay, displacement means what? It's the shortest possible distance. No, you don't have to calculate for Zuha to go and to come. Right? Displacement means you just going, right? You're just going in one direction. You get me? Distance means going and coming back. So actually, if I'm talking about Zuha's displacement here, it's actually 0. And that's how we already found it. Okay, it's 0. You know why? Now we'll talk about this. Okay, I'll erase this question. Okay, entirely. This is something that I kind of remembered, something I always think about, okay? So now we're talking about now same thing. Now back to our initial this thing about me and I think Abida, no, someone I told, right? Me and Abida, right? This is something I randomly always think about. Okay, first I will talk about this scenario. This is not what I think about, but there's something I actually think about. I'll tell that later, right? So now me and Abida, right? Now if I am going to, let's say I'm going to Abida's house, and then I'm going to Abida's house, and then I'm coming back home, right? Can somebody tell me what's the displacement here? What is the displacement? Anybody give a good guess? From my house to Abida's house, I'm going for a short time, I'm staying there, and then I'm coming back home. So what do you think is displacement? Anybody? We'll see if there are any smart peeps here. Because this is a question they can ask. Let's say you're going somewhere and then you're coming back. Yes, very good. Suraya has told the answer, 0. Okay, let's see if it's the Ruke also say, right? So if you're actually going somewhere and then you're staying there for a short time and you're coming back home, the displacement is 0. But the distance, now this displacement, shortest possible thing that's traveled, no, that's the displacement, right? Displacement is the shortest possible. So basically, if I draw the shortest possible route, it's going to be the same dot. Starting also same point, ending also same point. So I haven't really moved anywhere if you think about it. It's 0 meters. I haven't moved, right? Initial point also same, final point also same. So therefore displacement is 0. But what about the total distance from my house and then I go to Abida's house? Maybe it takes 150 meters and another 150 meters. Maybe it would be 300 meters. That's the distance, 300 meters. The total path traveled. Displacement is going to be 0. So you know what I think about often. So I always think about this, right? So imagine you were, okay, this is something, I don't know if it sounds stupid, but if you're born in one hospital and if you die in the same hospital, your displacement is actually going to be 0, regardless of where you have traveled on planet Earth. If you're born in the same hospital and if you die in the same hospital, your displacement is going to be 0. So that's something I think about quite often, right? So yeah, that's what I want to say. So this. Remember this, okay? Because they can ask you in exam the questions and all of that, right? Okay. Right. So that's about displacement, to be honest. Displacement, that's how they can ask you. With the graph, they can ask you different questions. They might now let's do a past paper and see how they can ask, right? So if this is a graph, now sometimes it could be a triangle, right? In displacement, there's nothing about area, all of that, right? It's just that they will give a graph like this. And then let's say this is 50 meters. And then this is 20 seconds, right? And then this might be 0, right? So they can ask you the velocity. Okay, now let's try and see. Okay, displacement meter. So if you're already thorough with this lesson, try to write it with me. Okay, without just watching. You try to solve it before I solve it, and then send the answer in the chats. Right? Okay. So now they can ask you, what is the velocity of this? Now initially, I told you the equation of velocity, right? Velocity is equals to displacement over time. No, displacement over time. Harida. Okay. So from this, it's very easy. Okay. So why I said to you, now I'm going to answer your question. Why I said it's not just displacement over time, but change in displacement over time. Right? The reason why it is change in displacement, in your exam also, if you just say velocity is displacement per unit time, they won't give you marks. You have to say change in displacement per unit time. Okay, remember that. Change in, that is important, right? The reason is because the change in displacement, you have to get this change. You have to get this difference. Change in that displacement. This means, think about it, right? Forget this. If you're confused with graphs, it's a problem with maths, okay? So if you're thinking about displacement and you don't understand what is the displacement, what is the time, forget about this part of this axis. Remember only this y-axis. And then look at that. In your head, in your brain, you can erase this now. You're like good at it. No, even while you're listening to my what I'm teaching, you're probably not listening, right? So just like that, try to eliminate the x-axis when they ask you about the y-axis in the paper. When they ask you about displacement, forget about time. When they ask you about time, forget about displacement, this axis, right? When they ask you about both, you see both, right? So now what I'm talking about is change in displacement, right? So you have to only talk about the change in displacement. What is the change? You have to go with final displacement minus the initial displacement, right? Final minus initial, right? So that's going to be 50 minus 0. So final displacement minus initial displacement. Okay, final is what? 50 minus 0 meters. Okay, now we think about the time. Time also you have to go with the difference only, right? But we don't have to say change in time. We can just say 20 minus 0, right? Final time taken 0. So why I'm saying now you might feel like, Miss, this is stupid. No, why should I write 0? Why? You might get it when I do another advanced question. For now it is 0. But there are instances where the initial will not be 0. Sometimes the graph could be a bit abnormal, right? I'll show you instances like that as well. So can you all send me the answer? I mean, it's after this, it's just maths, right? So I'm asking you the answer. What is the answer? What's the velocity? Okay. What is the velocity? Maths men, maths. Maths done at the. Yes. Suraya, correct. But your unit is wrong, right? So yes, Mariam, very good, right? It is 2.5, right? Basically, it's going to be 50 divided by 20, no, 0, 0 cut. 5 divided by 2 is 2.5, no? So 2.5 meters per second, okay? So that is how they can ask you, but this is a bit too babyish to ask, so they might complicate it a bit. So why I said change is important is sometimes in your paper, they can do this. They can do this dirty work, okay? They can do a dirty work like this. I mean, they usually do this for A levels, right? For all, I don't think so. Hopefully not, right? But I think they can. They can do this, right? So the starting point is really here. Let's say 5 meters, 10 meters, 0, right? And then we go here with, I think, 50, right? So when it becomes like this, right? Sometimes you might be like a big shot and be like, I don't have to put change in displacement. I'll just put it displacement. So when you put displacement, you know what will happen? You will put 10. You will put 10 over, I don't know, 50, right? 50, let's not put 50. Let's put 2, will you? Okay. 10 over 2. And you will nicely get the answer as 5. And you'll be happy and you'll come home and understand, oh, I got it wrong, right? 5 what? Meters per second, right? So that's why you have to find the change in displacement. Why? It goes as the final displacement minus the initial displacement. This is the initial part, right? These dotted lines are there, just it's there. But what really matters, what is our graph here, is just this line. This is our graph. You have to only focus on this line. Dotted lines, that's not our focus at all. This is the graph. That is only what is important to us, right? So this is the starting point. This is the ending point. So the change in displacement is 10 minus 5. Okay. Then what is the change in time or the normal time or whatever? That's going to be 2. So basically 10 minus 5 is going to be 5. 5 divided by 2 is going to be what? 2.5. So see the answer that you have got and the answer that it can be is too different, right? So that's why always you have to write the change in displacement. Okay. So yeah, that's about that. Maybe we can try to do a past paper, right? So that's about distance, displacement, all of that. Let us try to do a past paper question. So like you might notice that I'm not going in the order your teacher, your school teacher, or whoever teacher taught you, right? Because we are doing a crash course here, not a I don't know, school theory lesson now. So I can't really go one by one. Small, minor details I might not do because that's not really important to us, right? Okay. Let us try 2021. Sixth question. Let's see. Sixth question. Sixth question. I will give you all a break. Oh my God, it's 9:02. How fast? Okay. Can you all? Okay, I did not teach you all acceleration. No, no, let's not do this. Let's go to 2023. 19th question. 19th question. 19. 19th. Okay, can you all try this? We'll just give it a try. It might feel a bit, no, it's not hard. Can you all try the 19th and send me personally? 19th question. If you have done past papers, now if you are students who are doing exam in December, these are all SAPPA, okay? You all would have done this paper before also. But you know, sometimes these questions that you are doing now, it can come in your paper. Same question can come, maybe in essay. So always do past papers, okay? Stick with past papers, stay with past papers, live with it. So that's why I highly advise all to past paper. My students are quiet today. I'm a bit scared now. Mariam has sent the answer. We'll take a break, okay? But we just started. No, I feel like we just started. I don't know why we should take a break, but do this and send me. I will explain to you all how to do it, but try this and send the answer personally, okay? Always draw a diagram, okay? It doesn't matter how simple the question is, how hard the question is. Draw a diagram. Don't worry, miss, we are here. Okay. Glad to see that you're here, Mariam. I told her that my students are dead. Okay, there they are. Okay, Hasna has sent me answer. To be honest, I didn't try this question. I had to try it and only see. So I will try and see. Okay, Hasna has sent me an answer. Let's see. Wait, let me check if the answer is correct. Hmm. Others, what about the others? You are still doing? Draw a proper diagram. Okay, if you all can't attempt, if you all don't know, say you all don't know. Riha correct, Hasna correct. Mariam, check your answer because this is a very tricky question, okay? You have to read the question carefully and you have to listen. Mariam, check your answer. Suraya, check your answer. Riha correct, Hasna correct. Who else? I can't see who sent. Yumna, check your answer. Shima, check your answer. But I don't know if you sent that for previous one. I'm not sure. Wait. Who else? There are, I can see people are sending, but I can't see where the Chat please disappear. Okay, Zuha correct. Asma, check your answer. Huda correct. Right. Okay, right. So I'll go to this thing, right? So this one you have to be careful. Question like is easy, but you have to be careful. That's why I said draw a diagram, right? So now we'll say there is a ship. Now I can't draw a ship, I'll draw a boat, okay? Oh wait, I'll stop sharing. Okay. So there is a ship, it seems. And in that question, they are saying, okay, okay, so to the bottom of the ocean. So this is the ocean, now this is the sea, right? Always draw a diagram, right? For physics, whatever questions, not only this lesson, whatever physics, maths, or whatever. Maths, I don't think you can draw a diagram, but for physics, you have to draw a diagram, okay? So like, this is the ship. From the ship to the bottom of the ocean, they are saying the depth is, what, 2,880 meters. Okay. For a what? I forgot. For a ray, right? What was it? Ultraviolet. Wait, I can't remember. Wait, let me see. Let me see. I can't remember what ray. Ultrasonic. Yeah, ultrasonic wave, I think. Some ray, something. That's not very important to us. Ultrasonic wave, I think. So it is going 4 seconds, it seems, to go and come back. The point of our question, the turning point or the climax of the question is they have said to go and come back, not just to go. To go and come. This is where you have made a careless mistake. So you read the question, right? Okay, so if they said to go and come back, that means maybe the wave is going like this. To go and to come back, it's taking 4 seconds. To go and come back, it's taking 4 seconds. But the depth is what? 2,880 meters, it seems, right? So they are asking what is the speed, right? What do you mean by speed? Speed is equals to distance over time, right? Whatever the total distance or whatever over time, right? So what most of you have done is that you all have just taken the distance as 2,880 meters. And you all have put the time as 4 seconds. This is wrong. Okay, and you all would have got 720, right? Why this is wrong is now you must understand that maybe, to go and come, no 4 seconds. That means if you are going to take 2,880 meters, then maybe you have to take only to go. Maybe you have to take only, okay, to go only you have to take. That means it's not 4 seconds. What is it then? It's going to be 2 seconds just to go. Then you can either take it like that, because it should be same, no? You can't take to go and to come for time and then just to go, it's going to be this thing, what's that? You can't do that, right? If you're taking the meters just to go down, then that means the time also should take from here to here, right? The time is from here to here is going to be just 2 seconds. To go and come back, it's 4 seconds. So therefore, you can just say 2,880 meters, 2 seconds. The answer would be 1,440 meters per second. Okay. Or if not, you can also do like this. This is one way of doing it. If not, what you can do is keep the time like that. Okay, to go and come, the time is 4 seconds, right? To go and come, the time is 4 seconds, no? To go and come, it's 4 seconds. Then what you do is to go and come, you take the distance also. Because right now, currently, if you're taking this distance, it's not distance, it's a displacement. You see, the shortest possible distance between 2 points, you're taking the displacement. Maybe that's why you got a mistake. You thought they're asking for velocity, and you have just taken the displacement, which is the shortest possible length, right? If you're taking the distance, you have to take the distance to go and to come, right? That means it's going to be 2,880 meters to go and another 2,880 meters to come back. That means you have to add another 2,880 meters. That's going to be 5,760. And then you can divide it. 5,760 divided by 4 seconds. So the people who got it wrong, did you understand? They got it wrong. Somebody had got third answer also. Third answer, that can't even be an option. So first answer means I can excuse you all because everybody makes the mistake, right? So did you understand all good? If you understood, can you raise the hand, please? If you have any questions, please ask, okay? stop me and ask if you have questions. All good, right? Yeah. Okay. All right. I think somebody is unmuted, no? Okay. Right. So that's about that. So we see we did one MCQ. So that MCQ is a bit tricky, right? You might feel confident and you'll come home and you'll be all happy thinking that you got the mark. But the moment you check the marking scheme, all your this thing would have gone. Like all the confidence you had would have gone. So be careful, right? In that panic mode in exam, sometimes you might make mistakes like this. So try not to, right? Okay. So yeah, so if you, I think we'll take a short break and come back. Right now it's 9:13, no, because we might have to do until 10 today because I started late. So let's come back now, assuming that's 9:50. Let's come back at 9:25. 9:25, okay? We didn't do a lot, but we'll have to go with the graphs. So 9:25, please come back. All right, so I hope you all are back after having a nice dinner if you all had dinner. Right, okay. So I have to start on time, so I'll start right now, right? So if your friends are not here, if their phones are just there, and if they're not here, ask them to come back. So yeah, back to this thing, right? So now I was thinking, let's go with the graph, right? There are a few things to talk about the graph. So it's like this, right? Now, since this is day one, right, I might take another 2 more days to finish this the chapter, right? A day or two, right? So obviously I won't be able to cover the entire lesson right now, but we will do somewhat so that we can cover the MCQs at least and finish it off, right? Okay, so now about these graphs, it should be like a revision to you. If you have studied this lesson, this is something that you all have studied already, so it should be like a mere revision, right? Okay, so now we'll go to the graphs, right? So when it comes to the displacement time graph, right? So you can draw now. You have to know this, right? So this is something you're going to draw on the tute, but first watch, right? So when it comes to the displacement time graph, like I said, I don't know whose house I took as an example, but I said that displacement time graph, if it goes like this, right? If it is a slope like this that is going upwards, right? This means it is having a constant velocity, right? What does this mean? It means it has a constant velocity. So a displacement time graph, if the slope is going upwards, remember it, right? Sometimes you might feel like it's a bit hard to remember and all of that. Just remember it somehow. I'm going to give it like a summary, right? So if the displacement time graph is going like this, upward slope, right? It is constant velocity. The same thing, if I put it in a velocity time graph, okay? Think about it from a velocity time perspective. So if it's a velocity time graph, and if it is having a constant, forget about the displacement time graph, think about velocity time, right? And this velocity time graph, if it is giving a constant velocity in a velocity time graph means if it's constant, it has to be a line like this. In a velocity time graph, if it is going to be a constant, it has to be a straight line, right? But in a displacement time graph, if it is increasing like that, it's going to be a constant velocity. I'll tell you another relationship to remember, right? It's also constant velocity. Okay. Now, speaking of acceleration, what is acceleration? First, I have to tell that because before I say that, I can't just go to the graph now. So, acceleration means velocity. Now, I'll just write the equation here and I'll erase it, right? Acceleration equation is velocity over time. Velocity per unit time. Again, it should be change in velocity, okay? Change in velocity per unit time. So now see, okay, in this lesson itself, we are only talking mainly about displacement, velocity, acceleration. I mean, obviously, we speak about mean speed, what distance. We do speak about them, but these are like the main characters of this lesson, right? Displacement, velocity, acceleration. So with these three only, all the questions, everything will come, right? So that's why you should remember the equations as well, right? So the equation for acceleration is change in velocity over time, right? So that means, right, if the velocity constant is like this for the velocity time graph, for the acceleration, you can't, now if it's a constant velocity, it will be 0, right? Now, if you feel like it's too much for you to bear and understand why, I would say, physics is not about memorizing, but it's mostly about understanding. But if you feel like it's a bit hard for you to remember, memorize it, right? Memorize this, the graph like this, okay? It's not a good advice to give to memorize because science is never about memorizing. But if you feel like sometimes, even when I was doing O levels, for me, acceleration time graph, I used to be very confused. Okay, I didn't know why or what or anything, right? So whenever I feel confused, what I did was for acceleration time graph only, I memorized. Now for this, I can understand the velocity time graph, if it's a constant, it will go from here. Acceleration time graph, if you're going to draw the constant velocity graph for this, it's going to go through 0, right? It's going to go through axis. It's going to be a straight line through the axis. Okay, I mean to the x-axis, right? So this is the constant velocity in acceleration time graph. Okay. So all this is constant velocity. So if it is shown in a display, so the problem with you is sometimes you get confused with displacement velocity, the time graphs. Now sometimes you mistakenly, now we'll say now previously in the previous question, the question was like this, right? I do a trapezium. No? So when I do a trapezium, I do a displacement time graph. Now displacement we usually say it as S, okay? You might ask why is it not D? Because D is distance, right, sir? I mean, well, D is something else, I can't remember, but S only we denote for displacement, right? So don't mind it. In short form, we say S, but you don't write as S, you write as displacement, right? So you get confused with the trapezium drawn on this graph and sometimes with the VT graph. You get confused. What is the difference? What is this? What is that? That's only your problem usually in this lesson, right? So that's what I'm clarifying to you in a summarized version, right? So displacement time, if it is going like that, if it's an upward slope in a displacement time graph, it's a constant velocity. If in a velocity time graph, the constant velocity is gone like this, right? Acceleration time graph, constant velocity goes like this. So what I want you to do is on the cute, I want you to write this, right? Because this part of the now, sometimes you might not find it familiar or you might not understand it. When you do questions along with looking at this, it will help, right? Wait, give me a second. Let me check it. Yeah, go to the tute. Where is the tute? Yeah, go to the tute and draw it here. Under constant velocity, you're supposed to draw the slopes, right? This one goes like this, but you have to write it, okay? Here, displacement. Make sure you write the axis properly. Name the axis, put the unit, displacement time. You don't have to write constant velocity the way I written. It's already put up, right? And if it's a velocity time graph, if it's a VT graph, it's gonna go like a straight line, like this. If it's an AT graph, AT means acceleration time graph. Write it fully, okay? You have to write the full acceleration and in brackets, you must put the unit. It's compulsory to put the unit, okay? And you have to also state 0, 0. Sometimes when I'm lazy, I don't put it. They can, I think they give marks for this. You have to put 0, 0, comma 0 because it's starting at 0, no? Label the axis, put the 0, put the graph, right? And acceleration time graph, it goes from here, constant velocity. It goes straight, okay? Goes straight over here. So make sure you do that, right? I know it won't take a lot of time, so I'll just jump to the next part, right? So make sure you do it, right? Okay. So next, I'm going to go into, now this is about constant velocity. Constant velocity, it's going, now constantly it's going like this. Okay, now before I jump to the next part, my bad, right? So if you take this thing, right? Let's say, now this is a displacement time graph, right? Not displacement time graph, let's go to velocity time graph, right? So when I go for a velocity time graph, okay, I'm just jumping into the climax of the lesson, right? I'm not going step by step. I'm just jumping into the direct part of the lesson, right? So when it comes to velocity time graph, the area under the velocity time graph, let's talk about this area, okay? 40, and then we go 4, right? The area under the graph. Now this is the graph. No, this is what you call as a graph. This thing, the line here is the graph. Okay, the area under the graph gives you the displacement. What does it give you? You have to know this, right? The area under the graph will give you the displacement. So what is this area under this graph? 40 times 4, right? The breadth times the length, maths, right? So the area under this graph would be 40 times 4 is 160. The area under this graph is going to give you what? The displacement. Okay, this one, I don't know how you're going to know it, but remember, right? Area under a VT graph. Area under VT graph gives you the displacement. So area under the AT graph, right? Area under the AT graph. Now, here there is no proper area, but let's just assume for an instant, right? Like I'll just not take it as constant velocity. Let's say there is an acceleration, okay? Let's say somehow there is an acceleration over here. Okay, somehow there's an acceleration. Let's just assume, will you? So the area under the AT graph will give you what? Can somebody guess then? Oops. If area under the VT graphs gives me displacement, what will the area under the AT graph give me? The acceleration time graph will give me what? Somebody, anybody? Area under the VT graph is giving me the displacement. Then area under the AT graph will give me distance, no. See the pattern, okay? It's a pattern. It's a good pattern. That's why I'm putting everything in one. So area under the VT graph, the velocity time graph, is giving me the displacement. The area under the acceleration time graph is very good. It's giving me the velocity, right? So remember that, right? So area under this graph is giving me displacement. Area under the acceleration time graph is going to give me the velocity. Area under AT graph. Okay, I'll just press AT graph, VT graph, but you have to say acceleration time graph is going to give me the velocity. So each time if they give you an acceleration, I don't think this is not properly given to you, but sometimes they can, right? They might give you an acceleration time graph and be like, find the velocity. Then what should you do? Find the area under it, right? So to be honest, for displacement, there's nothing there. Okay, find the area, there's nothing there. So this is about the area finding, right? So what I wanted to do is, this one I have not included anywhere in the tube, right? These two. So I wanted to draw these two graph again and put this summary under, maybe there is that memes, no? Can you all write it here? Can you all write it here, somewhere here? Once you are done, raise the hands, okay? You don't have to draw this. You can just draw these two, right? These two, put it side by side, okay? So these are some key points for you to do questions. Okay, this is where you all go wrong. They might ask, find the area. They'll give you a VT graph and they'll be like, they won't tell you to find the area. They'll be like, find the distance. You might wonder velocity time or they'll give you, no, where, how can I find the distance, right? So you have to find the area and only find it. Same with an AT graph. If they give you an AT graph by any chance and they want you to find the velocity, you find the area, right? Once you're done, please raise your hands, okay? Because I'm waiting till you're finished to go to the next part. Okay, since most of you are done, let's go to the next part. Right. So there is a reverse. Okay, so now for this, there is a reverse this thing to go with. Now this is area. No? So now, right. So now let's say for an instant, right? Not so. So it was like this, right? Okay. So here we're going to talk about velocity and displacement, right? So when I find the gradient, now this is maths, okay? So when I find the gradient of a displacement time graph, it's going to give me the velocity. When I find the gradient of a velocity time graph, then what will it give me? Tell me now, it's a pattern now, right? Now gradient means what? Y equals mx. Now you have been studying the gradient, right? Y over x difference is going to give you m. That is maths again. So gradient is equals to what? Okay, I'll not complicate it. Gradient simply means the y-axis difference. That means y2 minus y1 over x2 minus x1. That's the gradient, right? So when you find the gradient of a displacement time graph, somehow you find the gradient, let's say, the gradient of a displacement time graph is going to give you velocity. Then if I find the gradient of a velocity time graph, okay, I'm not going to find it, I'm just saying it to you, right? Gradient of a velocity time graph is going to give me what? So gradient of st is going to give me velocity. Gradient of a vt, what is it going to give me? Somebody, anybody? It's a pattern, right? I'm making a catch patterns. Yes, Suraya, very good. Okay, it's going to give you acceleration, right? It's going to give you acceleration. Okay. So obviously for acceleration, there's nothing like the gradient of acceleration. I don't know what will give. So now it's a pattern. Now you get the pattern, right? So when you now if they ask, if they give you a graph like this and be like, find the what? Find the acceleration. Sorry, find the velocity, right? You have to find the gradient. Gradient kya it's nothing, right? Gradient means now what we did earlier only, right? Velocity is equals to what? I mean velocity, yeah. Velocity is equals to what? Displacement over time, no? Displacement over time, right? Velocity is equal to displacement over time. What is displacement? It's basically the y difference. That's only displacement, no? And what is time? The x difference. You get me? So that only I have put in fancy terms as gradient. Gradient is basically the velocity. So you see the y difference over the x difference. What is the y difference? Displacement. X difference is time. So gradient is equals to the velocity. So that way also you can find, right? So either way you can use either the gradient way or the velocity way, something, whatever, the equation or the gradient. But the gradient one is much easier. Okay, either way you get the same answer, right? So this is another thing that you have to remember. So please put this also if there's no space there. I don't know if you have space here. I don't know if you have space here to put this. Oh God, my board is so messy, no? Put it somewhere, at least on a full scap or something. Okay, somewhere, I don't know, full scap and attach it, right? Or if there is space here, just write it here. And I hope you have written the acceleration equation as well with the unit. The unit of acceleration, I didn't tell you, no? Yeah, so acceleration unit is, you all know it already, man. So anybody tell me the acceleration unit? Somebody. I know all of you have studied this lesson, so tell me. Velocity over time. Change in velocity, my bad. Change in velocity. Let's do a question, okay, after this, and then we'll wind up. There is more, okay, to this lesson. This is like just the, I don't know, the main part of the lesson, but there is actually more. Suraya, very good. Hasna, very good. Right. My students are dead. Okay. So Suraya, Hasna, very good. So it's ms minus 2. So how do you actually do is, you put the velocity unit, right? ms minus 1. Okay. Put the velocity unit ms minus 1 over the time s, right? And like I said, you take the s up. When you take the s up, what happens? Indices, right? S up is going to be s minus 2. It's going to be ms minus 1 times another s minus 1, ms minus 2. I know you all can't see that, so it's like ms minus 2 is the unit. Or you can just put like this also. Either way, right? Anything is fine. Whatever is easy for you, you put that, right? Okay, so yeah. So that's about that. So I hope you'll have drawn this. I'm going to erase it. So, okay. So these are key points, okay? These are important things from this whole lesson that I'm just giving out before you try out the questions, right? Okay, so let me go for a question. Let's go for 2020, I think 11th question. 2020. No, not the 11th one. Let's go for 2017. It's interesting. 2017, 17th question. It seems good. 2017, 7th question. This is not related to, it's not complicated. 17. This one, right? Can I try it and send the answer? It's very simple. On a horizontal ground, can I try and see? Send me the answer, okay? As soon as possible. Asma, that was fast. Okay, she has sent the answer. Very good. Others? Yeah, where was the energy when we started? Everything gone. My energy is also gone. Anyways, we'll wind up at another 15 minutes, right? I think we couldn't finish the other two graph. There is no rush. But for those who are not in my class, if you want the other two graph, maybe I'll draw it and send it to you, right? For the ones who want the other two graphs, right? I mean, the other four graphs. So, no, I think there's 6, no? Wait, how many graphs are there? So the remaining graphs, I will not be doing it. So if you need it, if you're not if you're not in my class, and if you want it, please text me personally, or maybe I'll send it on the group itself, then you can cover it. Riha, good. Hasna, good. Okay, so it's easy, no? It's an easy question, right? So my plan was anyways to do the past 10 years of MCQs and to do a bit of theory, right? Today, first day 1, right? Okay, so now what they're saying is point B is located to the east of A. So you know what is east, no? So there is first always draw, like I said, okay? B to the east of A, to the east of A. A is here, B is to the east, okay? And point C is located to the north of B. North of B, right? And then they're saying AB is going to be 3 meters. We all have done harder sums in maths, no? So this is nothing, right? And BC is 4 meters. So they are asking the displacement of this and of the ant in this motion. So this is the distance. Distance is what? If they ask the distance, be careful, okay? They can give you a question like this and be like, what is the distance? Distance is 3 plus 4, 7 meters. What is the displacement? Final, initial. Sorry, final, initial. Between the final and the initial point, the shortest distance. This is the shortest distance, right? So how do you find the shortest distance? By Pythagoras. Pythagoras, or you don't even have to use Pythagoras. You know Pythagorean triple, right? There is this Pythagorean triple, 3, 4, 5 triple. I can't remember the others, right? 3, 4, 5. There are like 1 triples that you learn in maths, right? You can remember in the form of Pythagorean triple, because if there is 4 or 5, then the answer will be 3. If it is 3 or 4, the answer will be 5, and so on, right? So here, the Pythagorean triple, 3, 4, the other one is obviously going to be 5. But if you want to use Pythagoras and find out, I will do it for you and show. So Pythagoras means what? I think it was something like a squared is equals to b squared plus c squared, no? So it's like you find the two sides, square it. 3 squared plus 4 squared, 9 plus 16. Okay, 9 plus 16 is what? 25, no? So a squared, and then you root it. Okay, 25 root, it's going to be 5. So that's how you find that one's answer. So answer is the second answer. 17 is answer number 2. Okay. All right. The 17 is answer number 2. So this is how it is, right? Okay. And then, yeah. So that is that question. So let us do another question as well, right? Before this thing. So let us go for 2000. Let's now the area under the graph questions we have to try now. So let's go to 2022, 26. Okay. 2022, 26. Let's try that. 2022, 26. Twenty 22, 26. Yeah. 2022, 26. This one. So we have to, can you try this and send me the answer? This is from what we studied right now about the area under the graph. See, the way I usually, oh wait, I haven't shared my screen, no? So stupid, wait. This one. So what I'm trying to do is now, even in your book, when it comes to any physics lessons, there is endless theory. Okay, but there is no point when it comes to physics. What is physics is the lessons that are in orange in your book. So those lessons, there is no point in just reading the theory and waiting. You have to pass papers, right? Then only you understand how they are asking you the question, right? From MCQs, you can practice to do essays also, but do essays separately, right? Essays, they haven't asked me, in 2025, they haven't asked a single MCQ. They can ask an MCQ for yours, right? So be prepared. You have done MCQs, you can do it. Hasna has sent me another triple, 6, 8, 10 triple. I actually don't remember. I did maths during O-levels, no, last, I can't remember. So there are like so many triples like that. Can you send me the answer quickly? Quickly. The faster you all do, the faster we can finish. You all know what to do, right? This one. I don't know if you're sleeping by now. Okay, Hasna has sent me an answer. What about the others? Are you all like half sleep, half awake? Now can sleep after O-levels, okay? Now sacrifice. Others, where are you all? Soon do it. It's not hard. Time, seconds, okay? They're asking the displacement from the velocity time graph. You have to find the displacement. Look at the, remember the logic I sent. I told you all, right? If they give a velocity time graph and if they ask you the displacement, then that means what should you do? You have to find the area, right? So find the area of the trapezium. Okay, Ria has sent me an answer with everyone's answers are different. Okay, I don't know who were you a student of Rizla and Hassan? No, I wasn't. I'm not. Ruqayya has sent me an answer. Suraya has made that's all of you are sending me answers, but the answers are a bit different. Let's see if the answers are correct, right? Okay, so what is the displacement? So you have to find the what? Like I said, the area under the graph, right? What is the graph? This is the graph. What is the area under the graph? Under this one. Okay, this is the area under the graph. So first color it, right? Sometimes you might feel like, why should I color it? I can see, don't be unapologetic. Okay, so try to color it, right? And then for the equation, so I used to be someone who used to be scared back in O-levels to use this equation, right? A, what is it? A plus B times H. Because sometimes when I use this equation, everything goes wrong. So if you have someone like me who used to be like that, okay, because this is the area of the trapezium, what? Equation. Area of trapezium equation is this. If you don't know, write it down. What I used to do instead, for the safe side, but this is time consuming, okay, so I don't recommend. But for the safe side, what I used to do is I used to separately find the area of the triangle and then find the area of this square and then find the area of the triangle. Very time consuming, I don't recommend, but because I used to be scared of that equation, I used to do this, right? That means I used to find separately the area of this, add it, separately to the area of this, add it, separately to the area of this, add it. I used to do that. That way also you can find the area, no? By the end of it, I have to find the area of the whole thing, right? So I should do like that. But I don't recommend you doing that. If you want, you do like that. It's going to take a lot of time, but I should do that. Instead, you can just directly put the area of trapezium equation to find the displacement. A plus B times H. What is A? What is B? This is another thing that used to confuse me, right? A and B, now height. When it comes to trapezium, if they're talking about height, it's this height. It's the perpendicular height, not the whatever the height. It's this height they're talking about. Let me erase it, right? They're talking about this height, right? This height, the perpendicular height, right? Not any other, not the slanted height, nothing. This height only they're talking about. That's only the H, right? In maths, you know that, right? And A means this one, this maybe the short one or the long one, anything, right? This is A. This is B. What is B? This is B. This is B, right? This is A, this is B, this is H. Now it's easy, no? Now you can find it easily, right? Half times what is A. Now finding A can be a bit, it might be a bit exhausting, right? So like A, now here it's 10, no, I mean if I check it from here to here it's 10. From here to here, it is 20. So I'll do the 20 here, right? And I'm just writing what is here on top there for my ease, right? 20 here, 10 here, right? Oh, it's not a trapezium, right? My bad. I don't know how my question became trapezium. Okay. I mean, it is a trapezium, but it's not a finished trapezium, no? It's not like a triangle. It's like this. That's it. Don't complete it. I just put it like that. But either way, it's a trapezium only, right? Somehow it is. Anyhow, even if you draw like this, it's like it's a trapezium only. So for these also, you can use this thing, right? But there is going to be a small this thing, okay? So this is A, this is B then. Okay, this is A, this is B. And what next? This is the height, no? So in this scenario, if you feel like I can't really find a trapezium or I can't really do that, what I would recommend is do my method. Okay. Let's go my method itself, will you, if that is confusing. Go with the area of the triangle first. And then go with the area of the square or the whatever rectangle. Right? What is the area of a triangle? Half times base times height. Half times what is my base? 10 minus 0, 10. What is the height? 10. Okay. Cut 5, 50, 50 what? 50 meters. Right? I found the area of the triangle. Next, I'm going to find the area of the rectangle, right? That means length times breadth. What is my length? 20 minus 10. Don't go 10, 20 minus 0, okay? 20 minus 10. This is the length. 20 minus 10 is 10 times, what is the breadth? 10. If you're finding it difficult here, it's a problem with your maths, okay? So go to your maths sir and ask maths teacher sir and ask them how to do it. So, and then you add both 100 plus 50, the total area, you have to just add the area of the triangle, area of the what? Square, right? It's going to be 150 meters. That's the total area. That's the answer. Answer is answer number 3, right? In the first 20 seconds, no, they're asking. First 20 seconds means until the 20, right? So everything under that area you have to find. So answer is answer number 3. People said 200, right? I don't know why you all said 200. Actually, you can do the trapezium also, but sometimes some of us or most of us, we find it confusing, right? Trapezium also you can do, right? So I usually do it this way. So this way is much easier for me because finding a trapezium is like, it's a bit hard, right? Isn't there only one triangle? Yes, I just saw it. I mean, I just saw it when I did it. Yeah, okay, correct. Right, so that's about that. So let's now, we have done that question. So let me go with another final question. One last question before we wind up today, because it's almost 10. We just have 2 minutes left. And as for the rest of the drafts, I'll send it to the group, right? Because I'm not hoping to finish it all at once today. Although it's a crash course, I don't want to crash everything in one day and mess your brain up. So we did enough questions. I think we did around almost 10 MCQs. So like you all are almost prepared, right? So I think I did almost all past 10 years of MCQs are done, I think. I think there are like around 2, 3 more left. If possible, I'll send those in the group as well so you can try it on your own. That means you have done all past 10 years worth of MCQ from this lesson already, right? We haven't even completed the question, the chapter, but you still have done it, right? Which is amazing, right? Yeah, I think I should stop screen sharing because, yeah, to show the board. So like if you all want, to complete, if you all have any errors that you all made, please feel free to correct it. And one last question, okay? Final millionaire worth question, 2023. Let's see. Do it quickly, okay? Then you can go to sleep. 2023. 2023, 36. Let me see, 36. Okay, this is a statement type, right? Which one is false? Can you all send me the answer? It's a statement type because we did so many sums, no? I mean, so many mathematical type questions. So let's go with the statement type. Send me the answer to this and then let's find out. Also, this is not the full chapter, okay? Like I have just taught, I think, quarter or like almost half of the lesson. There's another half to be done, right? But if you all have done it properly before, amazing, okay? This is like the intro. Okay, Hasna has sent the answer. Hasna is very fast. Alhamdulillah, that's good. Others, where I mean, Abida, Huda, Zuha, where are y'all? Send the answer, will you? Mariam. Okay. Rukia also has sent the answer, but Hasna's and Rukia's answer are two different. Let me see. Okay, I'm getting more answers. No, Surya, check your answers. Surya is sending me in MCQ. Surya is giving me multiple answers. So it's like, so I have to select the answer. No, no, not either of it. Okay, Huda, correct. It's okay. Okay, now that I'm saying that your answers are not correct, don't feel disheartened or don't feel listening because you are coming to class to learn, right? So it's okay to make mistakes. So, but by the mistakes, you have to be able to learn. Okay. Okay, Zuha, correct. Right. So I'll go into the discussion, right? Because it's already past 10, right? Okay. So here, this question, right? They have said which one is false, right? But we'll just go and see which one is true. So now the area covered by the graph gives the displacement. Now they're talking about a velocity time graph, right? So about a velocity time graph, they're saying that, okay, I'll just draw and it's show it on the board. Give me a minute. I'll draw it on the board and show you. Right. So in this question, they're talking about a velocity time graph, right? So like I told you, right? In a velocity time graph, right? Oops. Okay, in a velocity, in a VT graph, right? In a VT graph, right? So basically what really happens, okay? So like I said earlier, a velocity time graph, if you find the area, okay, it gives the what? It gives the displacement, no? So that's what they have told in the first option. So obviously the first one is correct. First option, first answer is correct because the VT graph is going to give you the displacement true, right? Let's go to the second. Second one, the graph starts from the origin of the objects, for objects starting their motion from state of rest. That looks a bit doubtful to me. Like I'm not sure if that's the answer. So I'll keep the second option like that. Okay, because I don't know if it's correct. Third one also the gradient of the graph is zero in a motion where the velocity varies with time. Okay, maybe that also looks a bit doubtful to me. So I'll keep that also. Let me go to the fourth one, right? The gradient of the graph gives the acceleration or deceleration. Didn't I say you that? I told you, right? Maybe if a velocity time graph is like this, right? I told you that the gradient, maybe the y-axis is different and the x-axis is different. The gradient is going to give you the what? The acceleration. So that is correct. Fourth one also correct, right? So second and third only, it's a bit doubtful to us. Let's go to the second question, second one again, right? Okay, let's go to third one. The gradient of the graph is zero in a motion where velocity varies with time. Is that correct? Is it always zero? Is the gradient of the graph zero? Now, if you take a velocity time graph, is the gradient zero, man? Like, if you, now you can find a gradient. No, it's not always zero, right? Now, what is a gradient? Gradient is equals to what? Y difference over X difference. I'll just press Y over X, okay? Y difference over X difference. Is the velocity time graph always like this? Is the velocity time graph always a straight line? Straight line means only zero. Is it always a straight line? No, right? It could be like this. It could be, I don't know, like this. It could be in any way. So gradient of the graph is not always zero in a motion where velocity varies with time, right? It's not always, you don't see velocity time graph always being like this. No, this is what you mean by gradient is zero. So that answer is automatically wrong. So let's see what the second answer is correct. The graph starts from origin for the objects starting their motion from the state of rest. True, no? So always it start from, if it start from rest, that means it's starting from zero. Velocity time graph was the same, displacement time graph was the same. So if it's starting from rest, that means it's starting from zero, like this. So if it is starting from origin, that means it's starting from what? That means then only the object is starting to move. If it started from zero, that means the object is starting to move in velocity time graph. It's like that. Okay. So you have understood, right? So the second answer is correct. So that's how you have to find the answers. Always find if you don't know how to find the false one, check what is right, and the remaining option would be false, right? Elimination method. Okay. Do you have any questions? Understood that question? Any doubts? So answer is answer number 3. I think some of you had said 2. Miss, I sent you as my corrected second answer as my correct answer. You said no. I did. I can't remember. Maybe. My bad then. I'm sorry. Okay, it's clear, no? Okay, so then shall we wind up the session? There's a bit, the other remaining graphs I'll send you all if you all want, whoever is not in my class. As for the others, we'll do it in class, okay? Do you have any questions regarding the entire session today? Because today we didn't complete the session, obviously, right? There is a lot more, there's a few more questions to do, and there's like a lot to do, right? Barakallah feek, Suraya. So yeah, let's wind up inshallah, right? So Jazakallah khair everyone for joining. And yeah, if you have any questions, you can stay back and ask. If not, we can wind up. Right. Bye. Wa alaikum salam. Barakallah feek.
Hi, Miss.
Yeah, take care.
Hello, Miss.
I said bye, take care.
No, Miss, it's Huda.
Yeah, Huda, what's up? You have a question? I
Yes,
thought you were saying
Miss.
bye. You're saying bye.
No, no, Miss,
Yeah,
I do. I have a question, Miss.
it's go on.
So, Miss, if I
Hmm?
were to do A levels in London, what would you say?
A-levels in London. Okay, shall
In
I? Yeah.
in the science stream?
So you're doing O-levels now, right?
Yes.
Okay. Shall we talk about this on WhatsApp?
Yes,
Because
please, Miss.
okay, yeah, sure. Okay, I'll clear it to you. All right.
Okay, Miss. Thank you, Miss. Bye,
You're welcome.
Miss.
No other doubts, right?
No.
Okay, all right, amazing. Okay.